Bam! Mr. Taru. In this algebra lesson, we are going to be defining what an equation is. We're going to work through 3 examples of classifying equations as either being open and closed and determining if they're true or false. We're going to work through 3 examples where we're given an equation and a possible solution and testing whether that number given is a solution to that equation. We're going to be not really solving equations, but identifying where along the number line a possible solution or where a solution to an equation will be based on analyzing a table of values. And then we're going to finish up with 4 equations where we're able to just solve them mentally. Because, you know, if you're watching this lesson and you're just being introduced to what, as you know, we are doing, defining what an equation is, you don't have any techniques, you haven't been taught any techniques to actually solve them. So we'll have a few of those. We'll solve them again mentally. Okay, so that's going to be quite a few examples, and I'm going to put timestamps to those examples in the description of this lesson so you can skip ahead if I end up talking too much in one point and you kind of get it and you want to move along. An equation is a mathematical sentence that uses an equal sign. So anytime you look in your book and you know there's some kind of collection of numbers and letters and all multiplied and added, subtracted, and divided together, whatever, and then somewhere in the middle or in between all of that mess, you see an equal sign, you are looking at an equation. An equation is an open sentence if it contains one or more variables. Now over here, this equation, not that I've completely finished all the definitions, but we see something with an equal sign and there's a variable. So this is going to be an open sentence. I'm kind of getting ahead of myself here because that's what these examples are for. But now we have another equation, I know, because again we have an equal sign, there's no variables, so that is a closed sentence. Depending on the value of the variables, an equation, or variable or variables, an equation can be true or false. And since we're just beginning our study of algebra, you know, all of our examples are only going to have one variable. An equation is true if the expressions on the left and the right-hand side of the equal sign are equivalent. They work out to be the same number on both sides. If the two sides are not equal, well then the equation is said to be false. Okay, so over here we're going to classify each equation as open or closed and then decide whether it's true or false. Are the two sides equal? And we see an expression, we have a constant or just the number by itself, but in math terms it's called a constant, and a term. And actually, well, really, both of these are terms. This has got a collection, a multiplication of a coefficient and a variable, and here we just have a constant by itself. And so thus we have an expression with 2 terms on the left-hand side, and on the right we only have 1 term. It happens to be negative 25. And is this open or closed? Well, on the left-hand side of this equation, and you're going to hear me say left and right-hand side quite a bit, the equal sign, of course, well, hopefully, well, maybe I shouldn't say of course. The equal sign is what separates the left and the right-hand side. We have a variable on the left-hand side, so thus this is an open equation. This basically there's an open place for you to put in a value. A variable is an unknown quantity, and really early on in your studies of algebra you could almost just think of a variable as an unknown value, like an unknown number. But we're going to become more sophisticated as we go through our study of algebra, and you'll see that this might just represent or be an open space to plug in another expression, not just a regular number. But for right now, that is a variable. That means it is an open sentence. And, you know, are these two sides equivalent? Is this left side truly equal to, equivalent to the right-hand side? Now, the right-hand side is just a number, negative 25. So for this to be a true statement, I would have to somehow show that the left-hand side is also coming out to be negative 25. Well, x could be 0, it could be 1, it could be negative 10, it could be 100. We don't know the unknown quantity that this variable of x is representing. So I have the left-hand side being, basically it could be any number. I don't know if it's true or false. I would have to be given, at this point in our algebra studies, I'd have to be given a value of x and asked to test whether, you know, if x is blank, then, you know, is it a solution? And that's what we're doing on the next page of these notes. So for right now, this is an open sentence, and I don't know if it's true or false. there's no way of knowing with an open sentence unless you are, again, given a value that variable is representing and you plug it back in and you check like we're going to do on the next page, or you can solve for the value of x that makes the left-hand side equal to the right-hand side, and we're going to learn that in a couple of sections from now, a couple of lessons from now. Here we have negative 11 plus 35 is equal to 21 plus 1. Well, there's no variables in this equation, so it is a closed sentence. And are the two sides equal? Well, on a number line, and I don't want to put 35 tick marks, but if you start at 0 and you go to the left 11 spaces, and then from there go back to the right 35, you're going to, get to a place on the number line that is going to be the answer, which is not another 0, but let's write ANS for answer. So, what that means, since you're moving like a left for the negative and a right for the positive value on the number line, then maybe you don't want to draw a number line for each one of these problems. You want to, when combining numbers of different signs, if they have different signs, you want to subtract those numbers. So 35 minus 10 is, 25. And 25 minus 1 is 24. So the left side is going to come out to be a value of 24. Oh, and so again, when you combine, I didn't finish my thought. When you combine numbers of different signs, you want to subtract those numbers. Assuming we're not multiplying or dividing. Subtract those numbers and keep the sign of the larger absolute value. So that is going to be 24. And if you looked at a number line, you would see that you were to the right. After that left and right movement, you'd be to the right of 0. Thus, your answer should be positive. And on the right-hand side, we have 21 plus 1. Well, that comes out to be 22. And those values, because we see the numerical value of the left and the right-hand side, those are not equivalent values. Those are not equal. So this closed sentence is false. Now, please, every time that you see a fraction, do not go grab your calculator. I teach everything from Algebra 1 all the way up through Calculus, and I'll have pre-calculus and calculus students, well, usually pre-calculus students, they get over it by the time they get to calculus, that still struggle with fractions because they just become completely calculator dependent. Well, if you have ever used a ruler or cooked with measuring cups, or there's going to be tons of applications in the real world that require you to handle some, at least some basic fractions. So we've got negative 17 over 3 plus 11 over 12 is equal to negative 5 plus 1/4. Now this is no variable, so this is going to be again a closed sentence. But we are going to have to do a little bit of work to make sure the two sides are equal. So here, if we're going to add negative 17 over 3 plus 11 over 12, we need common denominators. We need to find the lowest common multiple between 3 and 12. Well, the multiples of 3 are 3, 6, 9, not 19, 9, 12, 15, and the multiples of 12 are going to be 12 and 24 and 36 and so on. Well, we see right here our lowest common multiple is 12. I already have a denominator of 12. I need to take 3 and multiply it by 4 to get it to equal 12. So we're going to multiply the numerator and the denominator. Try not to drop my chalk. Multiply them by 4. Why am I doing 4 over 4? Because 4 over 4, 4 divided by 4 is equal to 1. And when we multiply by 1, we don't change a number's value. I'm just going to change the way that fraction looks. In case you need some fraction help. I hope not. So this is maybe where some of you want to skip ahead if you know your fractions really well. We have 4 times negative 17. Well, when you multiply a positive times a negative number, you get a negative answer. And 4 times 10 is 40. 4 times 7 is 28. And 40 and 28 is negative 68 over 12 plus 11 over 12. Now we need to combine these. We have our common denominators now. We're just going to add the numbers on top. And we have a negative and positive number. We're combining numbers with different signs, so we're going to subtract these. I'm going to kind of ignore the sign, but keep in mind that it's negative. 68 minus 10 is 78. 78 minus 1 is 77. But my largest absolute value is going to come from the 68, but it's negative, right? The original number is negative, so we have negative, and I forgot what the answer was, 68. Did I say that? I think I said the wrong number. 68 minus 10 is 58, and now it's 57. Okay, I'm pretty sure that I was talking well, I'll know when I look at the review the video whether I said something wrong. But whatever it was, we figured it out. Now we have 5 over 1, negative 5 over 1. Well, negative 5 over 1 plus 1/4, we need a common denominator there. And so now we're going to, let's see, get a different color chalk. We're going to multiply the numerator and denominator by 4 again. That was not really on purpose. Negative 5 times 4 is negative 20. Over 1 times 4, which is 4, plus 1/4. Now we have those common denominators. Negative 20 plus 1 is going to be negative 19 over 4. And we once again see that the left side and the right side are not equal. So this closed sentence is also false. Okay, and that is how you identify the difference between an open and closed sentence and how you determine if they are true. Open sentences, you're not going to be able to tell, but with the closed sentences, we look to see if the two sides are going to be equal. And now I am pausing again because I just glanced down to my notes, and I think I came to a decision a little bit too quickly. Now, what the heck? Those are not the same, right? I mean, they don't look the same, and but there's two ways I can check this. If you're going to look at fractions and tell whether they're equal or not, you can't really do that until the denominators are equal. So, this is reducible. And if you can see what it is reducible by, then, well, you can do that. Or you can see that, well, I know that if I take 4 and I multiply it by 3, I can get 12. So I either can make this denominator bigger to match the left side, or I can reduce this fraction, if possible, and get that denominator down to the 4. Now, 57 and 12 are both divisible by 3. And then we can divide the numerator and denominator by 3 and reduce the fraction, or I can come over here and multiply this by 3. And let's see, we got 4 times 3, which is equal to 12. And we've got, I really would prefer this to go straight down, but I'm out of room. And we have net positive times a negative, which is negative. And we have 3 times 10, that's the tens place, so 3 times 10 is 30. And 3 times 9 is 27. And 30 and 27 actually does come out to be negative 57. So this closed sentence is not false. The left side added down until you got to negative 57 over 12. We added the two fractions on the right, and we also got, after we multiplied the numerator and denominator by 3, 3 divided by 3 is 1. So I'm just making this look different, not changing its value. I got 57 over 12 again. So the left and the right side are equal. Thus, you want to now say this is a true statement, and not that I ever want to make a mistake on camera, but it does happen, and it will happen. I teach math. I've been teaching it for 19 years. You want to go slowly, maybe not talk while you're working, and then when you're done, check your answers, and just before you rush off, make sure that you've thought of everything and you meticulously looked through everything to make sure you didn't make any careless mistakes like I just did, but thankfully caught. Now, moving on to the next set of examples, we are going to be looking at what a solution to an open sentence is and going through 3 examples where we're going to be checking whether the given solution is actually, actually works, actually is one. No. A solution of an open sentence or equation is the value or values, even though we're just in this level of algebra, it's just going to be a value, but we'll be solving some equations later that have more than one solution that make both sides of the equation equal. So we're going to take 3 examples of this, and again, we're going to be very soon learning how to solve these equations on our own, but for right now we're just going to be given answers and asked to check them. So is the given value a solution to the given equation? So we have 12 minus x is equal to 25, and there is the x that is splitting the left and right hand side of this equation up. And is negative 13 a solution? If I plug negative 13, will I get the left-hand side to equal the right-hand side? Well, we should have, I know I have with my lessons, you should have already done some sections in your algebra book where you're asked to evaluate expressions. And that's exactly what I'm going to do here. I have an expression of 12 minus x. I've got a value of x is equal to negative 13. I'm simply going to plug that value into my expression and evaluate the expression, and then again see if it's equal to 25. And hopefully by now you are in the habit of making sure that, well, first of all, every single, do one thing per line. Keep your work really, really organized. I've had students, are just brainiacs. They can fly through the stuff, and they try and do too much in their head, and then by the end they've made a mistake. And, well, first of all, they have made a mistake they otherwise would not have if their work was neat. And secondly, I don't have anything to grade to give them any credit other than just knowing the answer is wrong. So when you do substitution, please put in a set of open parentheses, get in the habit of that. Take the x out, open parentheses in, and now we're going to plug in the negative 13. And we see that what we have here basically is 12 minus, and there's a little, basically a 1 sitting between the negative sign and the parentheses, and we have negative 1 times negative 13. Well, a negative times a negative is positive, so now we have 12 plus 13, and I don't know why I'm writing that way over there. 12 plus 13, is that still, again, we're checking to make sure this is equal to 25, and we have 12 plus 10. Now that's going to be 22, and then 22 plus 3 is 25, and that checks out. So 13, yes, 13 is a solution. And when you learn how to solve equations on your own, when you get that answer, or when you work out the material and you say that x, okay, so I solved this and x is negative 13, you can take that negative 13, plug it back into the original equation that you just solved, and do this and check your own work. So you'll be able to know if the answer you got right, well, if the answer you got was right before you turn it in and let your teacher grade it. Now over here we got fractions again because we need those practice with those fractions. We have 6 is equal to, again, a constant on the left side of our equation, and on the right side now we have the expression of 5x plus 4 1/2. Is x equals 3/10 a solution? When I plug that in, do we get the two sides to be equal? Well, that's going to be 6 is equal to 5 times 3 over 10 plus, now I'm going to do two things. I'm kind of fibbing a little bit because I told you to do one step at a time, and I'm going to do two. I've taken my value of x. I have replaced the variable of x with a set of open parentheses and substituted in the value that I was given to let x equal. And the way that this 3/10 is written is how I need to get this mixed fraction written. I need to rewrite this so it's an improper form, and that it's an improper fraction where the numerator is larger than the denominator. Mixed fractions are nice. You might recognize, I don't know, like a shoe size or something like that, or 4.5 feet. We like that visually to look at, but it's not very friendly to work with. So we're going to take this denominator. I'm going to multiply it by the whole number out front, so 4 times 2 is 8. And now as I swing back around, I'm going to add, and so again, we're multiplying here. We're going to add there. 2 times 4 is 8, plus 1 is 9 over 2. Okay, so now I'm going to rewrite this, and we're going to have, when you start working with fractions, really everything should look like a fraction. So we have 5 over 1 times 3 over 10 plus 9 over 2. And a couple things I can do here. I can either do 5 times 3 is 15 over 1 times 10, which is 10, and then I can reduce the fraction. These are both going to be divisible by 5, and we can divide that numerator by 5 and that denominator by 5. And again, 5 over 5, anything divided by itself is 1. So that division of 5 in the numerator, as long as I divide by the same in the denominator, I'm effectively, dividing by 1, or like before when you saw me find common denominators, multiplying by 1. So that's going to change the look of the fraction, but again, not its value. And now I'm running out of room to go down, so let's go sideways. 15 divided by 5 is 3. 10 divided by 5 is 2, plus 9 over 2. Once you get those common denominators, you only add or subtract the numerators, and 3 plus 9 is 12 over 2, which is equal to 6. Now I said that was one way to make your, your work look. But you could also recognize that, let's see, different color chalk. If we go this way, I can, and you may or may not need to do this, but I can write 5 over 1 times 3 over 2 times 5. Isn't 10 just 2 times 5 in factored form? Plus 9 over 2. Well, now we can see that we have we have one term in the numerator. There's no plus or minuses. This is one term. 5 times 3 is a term. It's in two factors. It's 15, but it's 5 times 3. That's one term. And now down here we have 2 times 5. So when you have look at me variables too, but when you have numbers and variables multiplied together, that's only one term, and you can see the individual factors. And when you have those factors, you can cancel factors out. You can cancel something that's being basically multiplied to something else, but you cannot cancel terms, and you cannot cancel parts of terms. So I'll tell you what I'm talking about in a second. But here we have 5 divided by 5 is going to be equal to 1. And there we have our 3 over 2 coming out again, plus 9 over 2. And we had that here that comes out to be 12 over 2, which again is equal to 6. So you can cancel, a lot of you would actually probably just write this. 5 divided by 5 is 1, and 10 divided by 2, or excuse me, I'm thinking of the answer. 10 divided by 5 is 2. So 5 divided by 5 is 1, 10 divided by 5 is 2, and there's your 3 over 2 coming out, a little bit quicker. Okay, now just because of all the errors that I see my students all the way from algebra all the way up to pre-calculus, honestly, they want to cancel terms. See how I canceled those 5s out? Like 5 times 3 over 5. Well, 5 times 3 is 15, and 15 divided by 5 is 3, yeah? Well, if it was, and nobody would do this with just regular numbers, but someone will want to do this later when you start working with variables. If there was a plus sign in the middle, and if it's a plus sign in the middle, 5 plus 3 is 8 over 5, and that's 1 3/5. But if you looked at that and said, oh, there's a 5 on the top and the bottom, let's cancel those out. Well, now you've got 1 plus 3, which is 4 over 1, and that is wrong. That is not the same. So the reason why that didn't work is because that 5 is being added to something else. That 5 is a term, not a factor like it was up here. So I'm giving you a lot of fraction review. Hopefully you're getting something out of that. Hopefully you're so good at fractions, I'm kind of boring you a little bit, but I see so many students that are weak with those. I just want to stress it. Now here we've got 7 over t, or 7 over 2t plus 2 is equal to 4, and I want to see if 2/7 is a solution. Well, same as all these other ones. We're going to write out the equation. We're going to put a set of parentheses where the variable is. We're going to go find the value that we're given to equal that variable and plug it in, just like when we were, again, evaluating those expressions. And, I think I've gone over this very, very well now. These are factors. These are being multiplied together. So 2 divided by 2 is 1, and 7 divided by 7 is also 1. And so this cancels out very, very quickly. You might also have been taught that when you multiply reciprocals, it always comes out to an answer of 1. Well, sorry for the static there. And now we've got 3 is equal to 4. No, I don't think so. So this is not, I kind of stopped checking that with this one here, but t is equal to 2 over 7. 2 over 7 is not a solution where when we plugged in our 3/10, we got an answer of 6 that did match the left-hand side. So 3 over 10, that is a solution. Now, what do we have left? We're going to now look at a couple of equations, and we're going to analyze the values. We're going to plug in some x's and look at the answers, look at the y values, and try and determine where along the x-axis, or what x value, what interval, where would the solution be. And that's coming right up. Bam! Example. Use a table of values to identify a solution. When you do graphing, these table of values are going to be called t-tables. And again, we haven't, thinking about the idea that we haven't been taught how to solve equations yet, and we're given this table of values, we're just going to try and figure out, just keep plugging in. I'm giving you the values, so you don't have to try too many numbers. But as you plug these into this expression, which one gives you the answer? Which one makes the left side equal to the right side, which is -2? Well, in this table of values of 2, 3, and 4, and our expression on the left-hand side is -3x plus 10, we're basically going to just do -3, leave a set of parentheses, plus 10, -3, parentheses, plus 10, and so on and so on. And just simply plug these numbers in and see what happens. We're going to first try a value of 2, and then 3, and then 4. Well, -3 times 2 is going to be -6 plus 10. And again, on that number line, if you were at 0, 1, 2, 3, 4, 5, 6, -6, and then take that and move back in the other direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and stop because there's a positive 10. We are 1, 2, 3, 4 units to the right, so -6 plus 10 is equal to 4. And now we have -9 plus 10, that's going to equal 1. And we have -12 plus 10, and that is going to be equal to 2. Oh, okay, so I have made the expression of -3x plus 10 equal -2 when we plugged in the x value of 4. So our solution to this equation, what x makes the two sides equal? Well, that is going to be that is going to be 4. And that's our solution. Now coming over here, we're going to do the same thing, and we're going to have 5 times 0 minus 2, 5 times 1 minus 2, 5 times 2 minus 2, and 5 times 3 minus 2. That's going to be 0 minus 2. So that's going to be 0 minus 2, which is -2. We've got 5 times 1, which is 5, minus 2, which is equal to 3. We haven't got to 11 yet. 5 times 2 is 10. Minus 2, that is going to come out to be 8. We're getting closer to the right-hand side of 11. And now we have 5 times 3, which is 15, minus 2, and that's equal to, wait a minute. I was trying to get the left side to equal the right side. And going from 2 to 3, when I plugged in 2, I got 8. When I plugged in 3, I got 13. I passed 11. So that means that somewhere between Mm-hmm. 2 and 3, a solution exists. So with our skills right now, that's pretty much all we can say is that, if I plugged in 2, I got a number that was smaller than 11. I plugged in 3, I got a number that was bigger than 11, which is 13. And so somewhere we must have had a y value that was, equal to 11 because we were under and then we were above. Now, this is a preview. Now, this is only the very beginning of algebra, so I don't want to really kind of go beyond the scope of the class. But you're seeing just a tiny hint. This is, when we eventually learn how to graph this, it is going to be a continuous line. And using the fact that we are below 11 and then above 11 and saying somewhere between 2 and 3 we have an actual number, a solution that makes the left and right hand side equal, that is called something called the intermediate value theorem. And you use that even all the way up to calculus, which is many years from now that you might be taking that class, which is still kind of an intuitive concept, but can be powerful even all the way up into calculus and beyond, I'm sure. Now, again, giving you a preview of what's going on, I'd like you to, we haven't done any application problems in this lesson so far, but to kind of see that you're going to have these type of problems, come up later on. And just in a few sections, we're going to learn how to solve two-step equations. And eventually what you're going to see is that to solve this, to get the negative 2 away from the x, we're going to add 2 to both sides and get 5x is equal to 13. And we're doing that addition because we want to cancel out the minus 2 that's with the variable. And now with the variable, we have a multiplication of 5. And to move that away and solve for x, we would do the opposite or inverse operation for multiplication, which is division. And x, well, 13 divided by 5, there's 2 whole values of 5 in 13. 2 times 5 is 10. And if you take 10 away from 13, that gives you a remainder of 3. So we have a mixed value of 2 3/5, not 2/3. Okay, and I'm just saying all the numbers wrong tonight. Yes, I am making this lesson after a long day of working as a full-time teacher. And we have 2 3/5. And indeed, 2 3/5, guess what, is somewhere between 2 and 3. Now, you weren't really supposed to, we're not really supposed to know how to solve these two-step equations. So we're going to look at 4 last examples to end our lesson where we're just going to look at the equation and try and figure out, just with our arithmetic skills, what variable or what the variable may represent, the number that we can plug into that variable to make the two sides equal, to find the solution. Use mental math to find the solution of each of these equations. And our first one is x plus 7 is equal to 12. And now we know a solution is a number that we can plug in for the unknown, the x or the y or the a or the b or whatever the variable is in our equation. And when we get done, simplifying that out, we get the same answer that is on the other side of the equation. So in this case, what can we plug in for x and get the left-hand side to equal 12? What plus 7 is equal to 12? 4? Let's see, 4 plus 7, that's equal to 11. No, what about 5? If we plug 5 in, we do get, 12 is equal to 12. So our solution to this equation is x is equal to 5. What number divided by 6 is equal to 3? Well, this division is coming out to be a whole number answer. There's no decimals. So this value of b must be some kind of multiple of 6. If it was not a multiple of 6, when you did the division, you'd get a mixed fraction or a decimal. So I think that 18 divided by 6, I'm pretty sure that, yes, that does equal 3. So our answer here is that b is going to be equal to 18. We got 56 is equal to 8y. Yes, variables can be on the left-hand or the right-hand side of the equation. No problem there. And we do have a variable and a number touching, a coefficient of our variable. And when those are touching, that's multiplication. So 8 times what is going to be equal to 56. And hopefully you know your multiplication tables. That is going to be an answer of 7. Yes, 8 times 7 is 56, so y is equal to 7. Sorry about the static. Here, let's try this. Is going to give us a correct answer. So y is equal to 7 is indeed a solution. Now this one, let's see here. This one is miscopied. We need to maybe change that 14 to a 15. We're supposed to be doing mental math here, and with that 14 being an even number, I don't expect you to come up with a decimal working out some mental math. But now that we have a 15, I'm looking here, we have 2 times x. Well, 2 times anything, 2 times any number is going to come out to be an even value. And then we're going to add 1 to it. So 2 times 6 is 12, and 12 plus 1 is equal to 13, so that's not going to work. Let's try 7. How about 2 times 7 plus 1? Well, 2 times 7, following the order of operations, you have to multiply first, of course. That is going to come out to be 14 plus 1, and that is indeed 15, which does match the left-hand side. And how did we get the right-hand side equal 15? We let x equal 7, and that was our solution. And that is the end of this lesson, defining and helping us understand exactly what is an equation in algebra. I'm Mr. True. Bam! Go do your homework.